Look up at the night sky tonight, and you're seeing only a tiny fraction of what's really out there. The universe holds secrets so strange they sound like science fiction, yet they're absolutely real. Right now, planets are raining glass sideways, black holes are stretching matter like taffy, and entire galaxies are on a collision course we can't even imagine. Space doesn't play by the rules we know on Earth, and that's exactly what makes it so fascinating. In the next few minutes, you'll discover 25 cosmic truths that will make you question everything you thought you knew about reality. Some of these facts will shock you, others might unsettle you, and a few will leave you staring at the stars with completely new eyes. This isn't just a journey through space, it's a trip to the very edges of what's possible in our universe. So buckle up, because your understanding of reality is about to get a serious upgrade. Here's something that might make you look at the moon a little differently tonight. Our closest cosmic neighbor is actually inching away from us year after year. Right now, the moon is moving about 1.5 inches farther from Earth annually, all thanks to the tug of war of tidal forces. Here's how it works. The moon's gravity pulls on Earth's oceans, creating the tides we see every day. But Earth's gravity also pulls back, and over time, this energy transfer slowly pushes the moon into a higher orbit. Now, you might wonder what this means for us in the long run. Well, as the moon drifts farther away, Earth's rotation will gradually slow down. Days will get longer, though don't worry, we're talking millions of years before you'll notice an extra hour of sunlight. Tides will also weaken, which could affect marine ecosystems and even coastal erosion patterns. But how do we know this is happening? The proof comes from tiny mirrors left on the moon by Apollo astronauts. Scientists fire lasers at these reflectors and measure how long it takes for the light to bounce back. By tracking these ultra-precise measurements over decades, they've confirmed the moon's slow retreat. So next time you gaze up at the night sky, remember the moon isn't just hanging there. It's on a very, very slow journey away from us. Now let's turn our attention to Venus, a planet that defies all expectations when it comes to time. Here's a mind-bending fact: a single day on Venus is actually longer than its entire year. That's right, while it takes Venus just 225 Earth days to complete one orbit around the Sun, the planet needs a sluggish 243 Earth days to spin just once on its axis. Imagine celebrating your birthday before you've even finished a single day. But Venus doesn't stop at just being slow. It also spins in the opposite direction of most planets, a phenomenon called retrograde rotation. Picture this: if you could stand on Venus, the sun would rise in the west and set in the east, completely flipping our earthly experience. Scientists believe this backward spin might be the result of a colossal collision billions of years ago, or gravitational tugs from the sun and other planets over time. And if that wasn't strange enough, Venus is wrapped in a suffocating blanket of atmosphere. Its thick clouds of sulfuric acid trap heat so effectively that surface temperatures soar to nearly 900 degrees Fahrenheit, hot enough to melt lead. The atmospheric pressure is crushing, equivalent to being nearly 1 kilometer underwater on Earth. This hellish environment, combined with its odd rotation, makes Venus one of the most extreme and mysterious places in our solar system. So while it might look like a tranquil, glowing jewel in our night sky, Venus is anything but peaceful. Now, let's journey to a world that sounds like it's straight out of a sci-fi fantasy, a planet made of diamond. Meet 55 Cancri e, a super-Earth located about 40 light-years away, orbiting a star in the constellation Cancer. This isn't just any rocky planet. Scientists believe its interior could be packed with diamonds thanks to its carbon-rich composition. Imagine a world where the ground beneath your feet glitters with precious gems, though you'd never get to see it up close. 55 Cancri e is about twice the size of Earth but nearly 8 times as massive, making it incredibly dense. Its surface temperatures soar to around 4,000 degrees Fahrenheit, hot enough to vaporize rock. But the real magic happens deep inside, where crushing pressures and scorching heat transform carbon into diamond. Picture squeezing coal with the weight of thousands of atmospheres while baking it at temperatures hotter than lava. That's how this planet's diamond core likely formed. What makes this discovery even more fascinating is how it challenges our understanding of planetary formation. Most planets in our solar system, like Earth, are oxygen-rich, with silicates and metals dominating their makeup. But 55 Cancri e is a carbon superstar, suggesting that under the right conditions, entire worlds can become cosmic treasure chests. Of course, mining it is impossible unless you fancy a trip to a scorching, high-pressure hellscape. Still, this glittering giant reminds us just how strange and wondrous the universe can be. Now, shifting our gaze to the king of planets, Jupiter, we encounter one of the solar system's most mesmerizing mysteries, the Great Red Spot. This colossal storm, larger than Earth itself, has been churning for at least 400 years, yet something strange is happening. Recent observations show it's shrinking, and no one knows exactly why. The Great Red Spot is a swirling tempest of gas, with winds screaming at speeds over 270 miles per hour. For centuries, it was so vast you could fit 3 Earths side by side inside it. But over the past few decades, it's been steadily shrinking, and now it's barely wide enough to hold 1 Earth. Scientists are racing to understand what's causing this dramatic change. Some think it's losing energy, slowly dissipating like a spinning top running out of steam. Others suggest smaller storms might be nibbling away at its edges, stealing its momentum. What makes this even more intriguing is what it tells us about gas giants. Jupiter's atmosphere is a chaotic dance of storms and jet streams, with no solid surface to slow them down. The Great Red Spot's endurance was once thought to be a testament to the stability of such systems, but its shrinking size hints that even the mightiest storms aren't permanent. This could reshape how we study weather patterns on other gas giants, like Saturn or distant exoplanets. So while the Great Red Spot might not vanish tomorrow, its slow fade reminds us that even the most iconic features of our solar system are ever-changing. And who knows, maybe one day future astronomers will look through their telescopes and wonder where the spot went, just as we marvel at its lingering fury today. Now let's zoom into one of the most extreme objects in the universe, neutron stars. Imagine taking the entire mass of our sun and crushing it down into a sphere no bigger than a city. That's the mind-bending density of a neutron star. But here's where it gets even wilder. These cosmic powerhouses can spin at speeds that defy logic, completing hundreds of full rotations every single second. To put that into perspective, picture a blender's blade whirling at top speed. Now imagine something the size of Manhattan spinning dozens of times faster than that. That's the dizzying reality of a neutron star's rotation. And as they spin, they unleash beams of radiation from their magnetic poles, sweeping across space like a lighthouse. When these beams point toward Earth, we detect them as pulsars, precise cosmic clocks blinking with unbelievable regularity. What's truly astonishing is how these stars reach such insane speeds. When a massive star collapses in a supernova, its core compresses into a neutron star, and like a figure skater pulling in their arms to spin faster, the conservation of angular momentum sends it into a frenzy. Some pulsars spin so steadily that their rhythm rivals the accuracy of atomic clocks, helping scientists test Einstein's theory of relativity and even hunt for gravitational waves. So the next time you glance at the night sky, remember, hidden in the darkness are celestial dynamos spinning faster than your kitchen appliances and shining beams of light across the cosmos. These neutron stars aren't just remnants of dead stars, they're some of the most extreme laboratories the universe has to offer. Now, let's turn our attention from the dizzying spins of neutron stars to the fiery heart of our own solar system, the Sun. At its core, temperatures soar to a staggering 15 million degrees Celsius, a heat so intense it defies earthly comparison. To put that into perspective, the hottest temperatures humans have ever created in labs here on Earth reach only a fraction of that, around 100 million degrees, and even then only for fleeting moments. What makes the Sun's core so unimaginably hot? The answer lies in nuclear fusion, the process that powers not just our Sun but every star in the universe. Deep inside the Sun's core, hydrogen atoms are squeezed together under such extreme pressure that they fuse into helium, releasing enormous amounts of energy in the process. This fusion is the reason the Sun shines, providing the light and warmth that make life on Earth possible. But here's the mind-blowing part. The pressure at the Sun's core is over 250 billion times greater than the atmospheric pressure we experience on Earth's surface. That's like stacking 50,000 Empire State Buildings on top of each other, except the Sun does it naturally, every single second, just to keep fusion going. Without this crushing force, the Sun wouldn't be able to maintain the temperatures needed to sustain these reactions. So while we bask in the Sun's light, remember that beneath its glowing surface lies a cosmic furnace, where matter is transformed under conditions so extreme they dwarf anything we can replicate. It's a reminder of just how powerful and how vital our nearest star truly is. Now, shifting our gaze from the Sun's blazing core to the far reaches of the cosmos, we stumble upon something utterly astonishing, a colossal cloud of water vapor floating in the depths of space. This isn't just any cloud, it's a cosmic reservoir so vast it holds 140 trillion times the amount of water found in all of Earth's oceans combined. And here's the kicker, it's located a mind-bending 12 billion light-years away, making it one of the most distant and unexpected discoveries in astronomy. Scientists first detected this immense water vapor cloud surrounding a supermassive black hole known as a quasar. Quasars are among the brightest objects in the universe, powered by black holes devouring surrounding matter and releasing enormous energy. But finding water, and so much of it in the early universe, was a shock. This cloud dates back to a time when the universe was just 1.6 billion years old, a mere toddler by cosmic standards. What makes this discovery so groundbreaking? It challenges our understanding of how quickly water, and by extension, the building blocks of life, could form after the Big Bang. Water molecules require oxygen, which is created in the hearts of stars and scattered into space when those stars explode. For such a massive water cloud to exist so early in the universe's history means star formation and stellar deaths must have happened at an incredible rate, reshaping our timeline of cosmic evolution. So next time you take a sip of water, remember, the universe has been brewing its own version for billions of years, on a scale so enormous it defies imagination. This distant vapor cloud isn't just a scientific curiosity, it's a clue to how quickly the cosmos can assemble the ingredients for life. Now, let's turn our attention to a planet that seems to defy logic: Mercury. You'd think the closest planet to the Sun would be a scorching wasteland from pole to pole, but here's the twist: Mercury has ice hiding in its craters. That's right, ice on a planet where daytime temperatures can soar to 800 degrees Fahrenheit. So how does ice survive in such a hostile environment? The answer lies in Mercury's unique geography. Deep craters near its poles never see sunlight, creating permanently shadowed regions where temperatures plummet to -290 degrees Fahrenheit. These icy pockets are like cosmic freezers, preserving water delivered by comet and asteroid impacts over billions of years. But here's another puzzle. Mercury has almost no atmosphere to speak of, which means there's nothing to trap heat or distribute water vapor. Without an atmosphere, any ice that isn't tucked away in those shadowy craters would instantly vaporize under the Sun's relentless glare. This makes Mercury's ice a rare and fragile relic, a snapshot of the solar system's history written in frost. Scientists first confirmed the ice using radar signals from Earth, which bounced back with the telltale signature of frozen water. Later, NASA messenger spacecraft mapped these deposits in stunning detail, revealing enough ice to cover Washington, D.C. in a layer 2.5 miles thick. Mercury's hidden ice teaches us a valuable lesson. Even in the most extreme places, the universe finds a way to surprise us. It's a reminder that water, and maybe even the ingredients for life, can pop up where we least expect it. Now, let's journey into one of the most bizarre and terrifying phenomena in the universe: black holes. Imagine getting too close to one of these cosmic monsters. The gravitational pull is so intense that it doesn't just crush you, it stretches you into a long, thin strand like a piece of spaghetti. Scientists call this gruesome process spaghettification, and it's as horrifying as it sounds. Here's how it works. A black hole's gravity is so strong that the force at your feet would be way more powerful than the force at your head if you were falling in feet first. This difference in gravity, known as tidal forces, would stretch you apart vertically while squeezing you inward horizontally. The result, you'd be pulled into a noodle-like shape long before you reach the black hole's event horizon, the point of no return. But the weirdness doesn't stop there, because time slows down near a black hole due to extreme gravity. An outside observer would see you stretch and freeze in place, almost like a glitch in reality. Meanwhile, from your perspective, if you could survive the experience, you'd be shredded atom by atom, adding to the black hole's mass. This isn't just science fiction. Astronomers have observed stars being torn apart by black holes in a similar way, their material stretched into glowing streams before vanishing into the void. It's a stark reminder of how extreme physics can get in the darkest corners of space. So while spaghettification might sound like something from a nightmare, it's a real and violent process that shows just how unforgiving the universe can be. And yet, it's also a fascinating glimpse into the strange laws of gravity that govern everything from falling apples to the fate of entire galaxies. Now, let's shift our gaze to one of the biggest mysteries in all of science: the fact that most of the universe is completely invisible to us. What we can see, stars, planets, galaxies, makes up just 5% of everything that exists. The rest, a staggering 95%, is made up of dark matter and dark energy, two invisible forces that shape the cosmos in ways we're still struggling to understand. Dark matter is the universe's hidden scaffolding. It doesn't emit, absorb, or reflect light, which means we can't see it directly, but we know it's there because of its gravitational pull. Galaxies spin so fast that they should fly apart, yet something invisible holds them together. That something is dark matter, an unseen glue binding the cosmos. Without it, galaxies as we know them wouldn't exist. Then there's dark energy, an even more puzzling force. Unlike dark matter, which pulls things together, dark energy pushes the universe apart, accelerating its expansion. Imagine blowing up a balloon that keeps stretching faster and faster on its own. That's dark energy at work. Scientists discovered its existence by observing distant supernova and realizing the universe wasn't just expanding but speeding up as it did. The challenge: we still don't know what dark matter or dark energy actually are. Countless experiments, from deep underground detectors to space telescopes, are hunting for clues. Some theories suggest dark matter could be made of undiscovered particles, while others propose modifications to gravity itself. Dark energy remains even more mysterious, with some speculating it's a property of space itself. What's clear is that these invisible giants dominate the universe, yet they evade our detection. They remind us that for all we've learned about space, the cosmos still holds secrets far beyond our current understanding. And that's what makes astronomy so thrilling. Every discovery peels back another layer of the unknown. Now, let's turn our attention to something closer to home, well, closer in cosmic terms: Saturn's breathtaking rings. These dazzling bands of ice and rock might seem eternal, but here's the twist: they're actually a fleeting feature in the solar system's history. Scientists estimate Saturn's rings are just around 100 million years old, which means dinosaurs roamed Earth long before they even existed. And they won't stick around forever. In another 300 million years, they could vanish entirely. So why are Saturn's rings so young compared to the planet itself? The leading theory suggests they formed when a moon or icy object strayed too close to Saturn and was torn apart by its immense gravity. The debris from this cosmic collision then spread out into the stunning rings we see today. But unlike younger, more chaotic ring systems around other planets, Saturn's rings are remarkably orderly, with distinct gaps and waves created by the gravitational tug of its moons. Here's the catch: those same forces shaping the rings are also slowly eroding them. Micrometeoroids and radiation chip away at the ice particles, while Saturn's gravity pulls material down into the planet in a steady rain. Over time, this process will drain the rings until they're gone. It's a reminder that even the most iconic features of our solar system are temporary, a cosmic blink of the eye. What's even wilder, other gas giants like Jupiter and Neptune have faint, dusty rings, but none compare to Saturn's grandeur. That's because their rings are either much older and fading or still forming from recent collisions. Saturn's rings are a snapshot of a rare, dynamic moment in our solar system's life, one we're lucky enough to witness before it's gone. Now, let's journey to the edge of our solar system, where time moves at a pace that's almost unimaginable. Pluto, that tiny, distant world, has a year so long it would span nearly 2.5 human lifetimes, 248 Earth years to be exact. That's because Pluto's orbit isn't just far from the Sun, it's also wildly elliptical, swinging closer and then farther away in a dramatic cosmic dance. At its closest approach, Pluto actually dips inside Neptune's orbit for about 20 years, but don't worry, their paths never cross. This stretched-out orbit means Pluto's seasons are just as extreme. Imagine a winter or summer lasting decades, with temperatures so cold that nitrogen freezes solid and forms glaciers. Speaking of glaciers, the New Horizons mission gave us our first close-up look at Pluto's heart-shaped feature, a massive plain of nitrogen ice called Sputnik Planitia. This icy heart isn't just for show. It's a dynamic, shifting landscape that drives winds in Pluto's thin, hazy atmosphere. And that atmosphere, it's barely there, a fragile envelope of nitrogen, methane, and carbon monoxide that freezes and falls as snow when Pluto moves farther from the Sun. New Horizons even spotted blue skies and towering ice mountains, proving this little world is full of surprises. So while Pluto might be small and remote, it's anything but boring. It's a place where time, weather, and geology operate on a scale that's truly out of this world. Now, let's turn our attention from the icy plains of Pluto to the rusty deserts of Mars, where a true giant looms over the landscape. Olympus Mons isn't just the tallest volcano on Mars, it's the largest in the entire solar system, standing a staggering 3 times taller than Mount Everest. Picture a mountain so vast that its base would cover the entire state of Arizona, with cliffs around its edges taller than the Grand Canyon. What makes Olympus Mons so enormous? The secret lies in Mars' quiet geology. Unlike Earth, Mars doesn't have shifting tectonic plates. Here, volcanoes don't get cut short by moving crust instead. They sit over hotspots, erupting lava over and over in the same spot for billions of years. That's how Olympus Mons grew layer by layer into the gentle sloped shield volcano we see today. And don't let its calm appearance fool you. This volcano was once a fiery force. While it's likely dormant now, its last eruptions might have happened as recently as a few million years ago, a blink in cosmic time. Imagine rivers of lava carving channels down its sides, building a peak that pierces the thin Martian sky. But here's the real kicker: Olympus Mons isn't alone. It's part of a family of massive volcanoes in the Tharsis region, a testament to Mars' volcanic past. Together, they paint a picture of a world that was once geologically wild, with forces shaping its surface on a scale we can barely fathom. So next time you look at Mars, remember beneath that quiet, dusty exterior lies a history of fire and fury, written in the slopes of the solar system's most colossal mountain. Now, let's shift our gaze from the towering volcanoes of Mars to the grand dance of galaxies far beyond our solar system. The Milky Way, our cosmic home, is on an unstoppable collision course with its neighbor, the Andromeda Galaxy. But don't panic, this cosmic crash won't happen for another 4 billion years. When these two galaxies finally meet, it won't be the violent smash-up you might imagine. Galaxies are mostly empty space, with stars so far apart that direct collisions are incredibly rare. Instead, the Milky Way and Andromeda will perform a slow, graceful merger, their gravity pulling and twisting each other into a new, larger galaxy over billions of years. Picture two swirling clouds of smoke gently blending together. That's how astronomers simulate this event. The real spectacle will be the night sky as the merger unfolds. Over time, Andromeda, currently a faint smudge in our sky, will grow larger and brighter. Eventually, the two galaxies will stretch and warp, their stars flung into new orbits like dancers in a cosmic ballet. Here's the surprising part: Earth and our solar system will likely survive this galactic reshuffling unscathed. The vast distances between stars mean our sun and planets will probably just drift into a new corner of the merged galaxy. So while the Milky Way, as we know it, will fade into history, the universe will gift us a front-row seat to one of the most breathtaking events in cosmic time. Now, let's step away from the grand cosmic collisions and into the eerie quiet of space itself. You might be surprised to learn that space is completely silent: no roaring engines, no explosive supernovas, not even a whisper. That's because sound needs a medium to travel, like air or water, and space is a near-perfect vacuum. Without molecules to vibrate, sound simply can't exist out there. This silence is a far cry from the dramatic explosions and laser battles we hear in sci-fi movies. In reality, if you were floating near a supernova, you wouldn't hear a thing, no matter how colossal the blast. But that doesn't mean astronauts are cut off from communication. They rely on radio waves which don't need air to travel. These waves carry their voices back to Earth and allow them to talk to each other, even though they're surrounded by utter silence. Imagine being in the vast emptiness of space, where the only sounds are the ones you create inside your spacecraft or through your headset. It's a strange and humbling thought, one that reminds us just how different the universe is from the noisy world we're used to. So next time you watch a space movie, remember, the real soundtrack of the cosmos is silence. Now, let's shift from the eerie silence of space to a world where the weather is anything but calm. Picture a planet where the rain isn't made of water. It's made of glass, and it doesn't fall gently from the sky. It whips sideways at unimaginable speeds. Welcome to HD 189,733b, a place where the atmosphere is as deadly as it is bizarre. This distant exoplanet, located about 63 light-years away, is a gas giant with a twist. Its atmosphere is packed with silicate particles, the same material that makes up glass on Earth. But here's where things get wild. The planet's scorching temperatures, reaching nearly 2,000 degrees Fahrenheit, vaporize these particles. Then, as they cool higher up, they condense into tiny glass droplets. But don't expect a gentle drizzle. Winds on this planet scream at 5,000 miles per hour, hurling the glass rain sideways in a relentless horizontal storm. So how do we even know about such an extreme world? Astronomers use tools like the Hubble Space Telescope to analyze the light passing through the planet's atmosphere. By studying which colors of light are absorbed, they can identify the chemicals present, like the telltale signature of silicate particles. It's a reminder of just how strange and diverse planets can be beyond our solar system. HD 189,733b, isn't just a scientific curiosity, it's a glimpse into the incredible variety of weather systems that exist across the cosmos. From silent space to sideways glass storms, the universe never fails to amaze. Now, let's take a journey from the scorching glass storms of HD 189,733b to the opposite extreme, a place so cold it defies the very nature of space itself. You might think the coldest spot in the universe would be some distant, empty void, but the truth is far more surprising. The coldest known place isn't light years away, it's right here on Earth in a lab. But before we get to that, let's talk about the reigning cosmic champion of cold, the Boomerang Nebula. Located about 5,000 light-years from Earth, the Boomerang Nebula holds the record for the coldest natural place we've ever found. With temperatures plunging to -458 degrees Fahrenheit, it's even colder than the background radiation left over from the Big Bang. How does something get that frigid? The nebula's dying star is expanding at a staggering speed, ejecting gas so rapidly that it cools to temperatures lower than the surrounding space. It's like opening a freezer door in a snowstorm and finding the air inside is somehow even colder than the blizzard outside. But here's where things get even more mind-blowing. Scientists on Earth have managed to create temperatures that make the Boomerang Nebula seem almost warm by comparison. In labs, using advanced techniques like laser cooling and magnetic traps, researchers have chilled atoms to within a fraction of a degree above absolute zero, the theoretical limit where all motion stops. That's colder than anything nature has produced, even in the deepest reaches of space. These ultra-cold experiments aren't just about breaking records. They help us understand the bizarre behavior of matter at temperatures where quantum physics takes over, revealing secrets about how particles interact in ways that defy everyday logic. From the icy grip of the Boomerang Nebula to the cutting-edge labs pushing the boundaries of cold, the universe and our own planet continues to surprise us with its extremes. Now let's shift from the icy depths of space to something unimaginably dense, a place where matter is packed so tightly it defies all logic. Imagine taking Mount Everest with all its towering mass and crushing it down into a single sugar cube. That's the kind of mind-bending density we're talking about when it comes to neutron stars. These cosmic heavyweights are the collapsed cores of massive stars that have gone supernova. What's left behind is so dense that a single teaspoon of neutron star material would weigh a staggering 1 billion tons. To put that in perspective, that's like squeezing the weight of every car on Earth into a tiny spoonful. How is that even possible? Inside a neutron star, the crushing force of gravity is so intense that atoms can't hold their shape. Electrons and protons are squeezed together, merging into neutrons, and the entire star becomes one gigantic atomic nucleus. There's no empty space, just a solid block of nuclear matter. If you tried to scoop up even a speck of it, the sheer weight would be impossible to lift. But here's the wildest part. Neutron stars aren't just dense, they're also tiny, typically only about 12 miles across. That means you could fit one inside a city, yet it would still have more mass than our sun. It's a reminder that the universe doesn't play by the rules we're used to. From the freezing cold of the Boomerang Nebula to the unimaginable density of neutron stars, space keeps showing us just how extreme and how strange it can get. Now, let's take a step away from the crushing density of neutron stars and land right back on our own moon, but with a twist you might not expect. When astronauts returned from their lunar walks and removed their helmets inside the lander, they were hit with something surprising. The moon has a smell. And not just any smell. It's been described as something like spent gunpowder, a sharp, metallic scent that clung to their suits and equipment. So why does the moon, a place with no atmosphere or weather, smell like anything at all? The answer lies in the lunar dust. Unlike Earth's soil, which gets weathered by wind and water, moon dust has been sitting untouched for billions of years, bombarded by solar radiation and micrometeorites. This constant exposure breaks down the dust into tiny, jagged particles with a lot of reactive surfaces. When astronauts brought this dust inside, the oxygen in the cabin interacted with these particles, creating that distinct gunpowder-like odor. But here's the kicker: the smell isn't actually gunpowder. Scientists think it's a mix of oxidized metals and other compounds like silicates that give off that familiar scent when they react. It's a reminder that even something as simple as dust can behave in bizarre ways when it's been isolated in space for eons. From the unimaginable density of neutron stars to the strange aroma of lunar dirt, the universe never runs out of ways to surprise us. Now let's turn our attention to something a little closer to home, but with a cosmic twist. You might think Earth has only one moon, but that's not entirely true. Meet Cameolwa, a mysterious object that dances around the sun in perfect sync with our planet, earning it the nickname Earth's second moon. But here's the catch: it's not a true moon at all. Cameolwa is what scientists call a quasi-satellite, a type of asteroid that orbits the sun in such a way that it appears to orbit Earth from our perspective. It's locked into a delicate gravitational ballet with our planet, staying close but never actually being captured by Earth's gravity like our familiar moon. This tiny space rock, only about the size of a Ferris wheel, has been tagging along with us for at least 100 years, and it's likely to stick around for centuries more. So where did this cosmic companion come from? One leading theory suggests it might be a fragment of our actual moon, chipped off during an ancient asteroid impact. Spectral analysis shows its surface resembles lunar rocks, hinting at a possible shared origin. Another idea is that it's just a passing asteroid that got trapped in this peculiar orbit by chance. Why doesn't it count as a real moon? True moons like ours are bound by their planet's gravity, while quasi-satellites are ultimately controlled by the sun's pull. They're more like temporary travel buddies than permanent satellites. Cameolwa's subtle presence reminds us that even Earth's neighborhood has its share of cosmic surprises hidden in plain sight. Now let's step into the strange world of stars that defy expectations. Imagine a star so cool you could theoretically touch it without burning your hand. Meet brown dwarfs, the cosmic misfits that blur the line between planets and stars. These mysterious objects are often called failed stars because they're too small to ignite the nuclear fusion that powers regular stars, yet too massive to be considered planets. What makes brown dwarfs so fascinating is their temperature. While most stars blaze at thousands or even millions of degrees, some brown dwarfs have surface temperatures as mild as 80 degrees Fahrenheit cooler than a summer day on Earth. That's right, if you could somehow stand on one, you'd find it surprisingly lukewarm, but don't let that fool you. Their interiors are still incredibly dense and hot, trapped in a perpetual state of almost but not quite becoming a star. So how do these oddballs form? Brown dwarfs are born from collapsing clouds of gas, just like stars, but they never gather enough mass to kickstart sustained fusion. Instead, they glow faintly from the heat of their formation, slowly cooling over billions of years. Some even have weather systems, with clouds of molten iron and sand swirling in their atmospheres, a far cry from the serene twinkle of ordinary stars. This cosmic gray area challenges how we classify objects in space. Are they dim stars or overgrown planets? The answer isn't clear-cut, and that's what makes them so intriguing. Brown dwarfs remind us that the universe loves to bend the rules, leaving us with wonders that don't fit neatly into any box. Now, let's zoom out to the grandest structure ever discovered in the cosmos, a web so vast it redefines our understanding of scale. The Hercules Corona Borealis Great Wall isn't just a cluster of galaxies. It's a colossal filament stretching an unimaginable 10 billion light-years across. To put that into perspective, the entire observable universe is about 93 billion light-years wide, meaning this single structure takes up more than 10% of it. That's like a single thread in a spider's web being wider than the distance from New York to Sydney, millions of times over. This cosmic behemoth is made up of galaxies, gas, and dark matter, woven together by gravity into a sprawling, ribbon-like shape. Scientists stumbled upon it while mapping gamma-ray bursts, the brightest explosions in the universe, which acted like cosmic breadcrumbs leading to this hidden giant. What's truly mind-bending is that structures this size shouldn't exist, according to our current models of the universe. The Hercules Corona Borealis Great Wall challenges the cosmological principle, which assumes matter is evenly distributed on the largest scales. So how does something this enormous even form? Think of the universe as a growing loaf of raisin bread, where galaxies are the raisins. As the bread expands, the raisins move apart, but gravity pulls some into clumps. The Great Wall is one of those clumps, just on a scale so massive it defies logic. It's a reminder that the universe still holds mysteries too big for our textbooks, waiting to rewrite the rules we thought we knew. Now, let's take a wild ride to one of the solar system's most peculiar planets, Uranus. Unlike the other planets that spin like tops as they orbit the Sun, Uranus rolls around like a barrel, tipped over at a jaw-dropping 98-degree angle. Imagine a bowling ball rolling down the lane sideways instead of spinning forward. That's basically how Uranus moves through space. This extreme tilt gives Uranus some of the most chaotic seasons in the solar system. For about 21 Earth years, one pole basks in constant sunlight while the other plunges into endless darkness. Then, halfway through its 84-year orbit, the roles reverse. That means if you lived near one of Uranus's poles, you'd experience a single day that lasts 4 decades, followed by an equally long night. So how did Uranus end up like this? The leading theory is that a colossal collision billions of years ago knocked it sideways. Picture a young Uranus minding its own business when a planet-sized object slammed into it, sending it spinning off kilter. The impact might have been so violent that it scattered debris into space, which could explain Uranus's faint rings and oddly tilted moons. This bizarre orientation isn't just a cosmic oddity, it's a clue to the solar system's violent past. While other planets bear scars from ancient impacts, Uranus wears its history in plain sight, tumbling through space as a reminder of the chaos that shaped our cosmic neighborhood. Now, here's something that might make you rethink your height goals. Space can literally stretch you taller. When astronauts float in microgravity, their spines expand, allowing them to grow up to 2 inches taller during their time in orbit. Without Earth's gravity compressing their vertebrae, the space between them loosens, giving astronauts a temporary boost in height. But before you start dreaming of a cosmic growth spurt, there's a catch. This extra height doesn't last. Once astronauts return to Earth's gravity, their spines gradually compress back to their original length, often causing significant back pain and discomfort. Some even report feeling like they're being crushed under their own weight as their bodies readjust. This phenomenon isn't just a quirky side effect, it's a serious challenge for long-term space missions. Imagine spending months or even years in space, only to return with a spine that struggles to support you. Scientists are studying ways to counteract these effects, from specialized exercise routines to artificial gravity systems, ensuring future astronauts can stay healthy on extended trips to Mars and beyond. So while growing taller in space might sound like a fun perk, it's a stark reminder of how profoundly our bodies rely on Earth's gravity and how much we still have to learn about living among the stars. Now let's dive into one of the most mind-bending ideas in modern physics. What if our entire universe is just a hologram? This isn't science fiction. The holographic principle is a radical theory suggesting that everything we perceive as 3-dimensional reality might actually be encoded on a 2-dimensional surface like a cosmic projector screen. Imagine your entire life, from the stars above to the ground beneath your feet, being nothing more than a detailed illusion painted on the edge of the universe. This wild idea actually has roots in black hole physics. Scientists studying black holes discovered something puzzling. The information about objects swallowed by a black hole seems to be stored on its surface, not inside it. This led to the realization that maybe all the information in the universe works the same way, with our 3D world being a kind of projection from a 2D boundary. It's like watching a movie on a flat screen but feeling like you're inside the action. Of course, not everyone's convinced. The holographic principle is still hotly debated, with some physicists calling it a groundbreaking framework and others dismissing it as unproven speculation. But whether it's true or not, the idea challenges everything we think we know about space, time, and reality itself. It forces us to ask, if the universe is a hologram, what does that make us? Just pixels in a cosmic display or something far stranger? Either way, it's a reminder that the universe still has secrets we've only begun to uncover. And with that, we've journeyed through some of the most mind-blowing mysteries of the cosmos, from a diamond planet to a universe that might just be a hologram. Each of these facts shatters our everyday understanding of space, reminding us just how strange and wondrous the universe truly is. Think about it: the moon is drifting away, Venus has days longer than its years, and black holes could stretch you like spaghetti. These aren't just fun trivia, they're glimpses into the forces that shape everything around us. So what's the biggest takeaway? Space is far weirder, wilder, and more mysterious than we often realize. Every discovery peels back another layer, revealing questions we didn't even know to ask. If this left you hungry for more, dive into books like Astrophysics for People in a Hurry, or follow missions like the James Webb Space Telescope. They're rewriting the cosmic rulebook as we speak. Now, we'd love to hear from you. Which fact blew your mind the most? Was it the neutron star weighing 1 billion tons per teaspoon, or the idea that Saturn's rings might vanish one day? Drop your favorite in the comments below, and while you're there, hit that like button and subscribe for more deep dives into the universe's biggest mysteries. The cosmos is full of surprises, and we're just getting started. Thanks for watching, and keep looking up.